Parts of a system. What all makes this stuff work? First part, ground loop heat exchanger. We need contact with the earth. We need somehow to get pipe in the earth. We need energy. So, ground loop heat exchanger. Well, a ground loop heat exchanger can be horizontal. I can lay this pipe in flat. If you don't have enough room, then we have to go down. A vertical system, a vertical heat exchanger. How deep do these go? Generally anywhere from 150 to 500 feet. But it could be 1, 2, 5, 10 holes. The number of holes is dictated by how much heat we need for the house. That particular one, I believe, was about 250 feet deep. Okay? However, when this hole is drilled, not a well, when this borehole is drilled, we insert this pipe, we now seal that hole shut. You see, there's no hole. It's clay, bentonite clay, called grout. We grout this hole shut. That keeps this pipe in thermal contact with the earth, gets a great energy transfer, but it also has an environmental benefit of sealing all the aquifers off, sealing this hole off so we can't have any kind of contamination. Another type's a pond loop. Pond's in contact with the earth, pond's a source of energy. We can basically bury our pipe in the pond, take it out and sink it in the pond. Great systems. So there's lots of ways of getting a ground loop heat exchanger in the earth. They're one of the better ones. Performance-wise, they'll all be the same. Question usually comes up, which one's better? Well, there's not better. Different doesn't always have to be better or worse. It's just different. They're all different, but they all should have the same operating results at the end. If there's a better, it's probably a pond loop, because I can get the same results with a lower installed cost. But that pond needs to be a minimum of 3/4 of an acre and at least 6 or 8 feet deep. That particular one was exactly an acre, 12 feet deep. So, ground source heat pump. Some people call it a geothermal heat pump. There's all types of ground source heat pumps. That's basically a completed one in the basement of a home. But that's generally our only mechanical equipment. There is no outdoor component. My outdoor component's buried in the earth. So the ground source heat pump and its associated equipment is really our only mechanical equipment. So that's the second piece of the puzzle. We've gotten the energy out of the earth and we've brought it to the heat pump. Now we've got to distribute it. We've gotten the heat from the earth. The ground source heat pumps extracted the energy, but I have to spread it around your house. Well, the only ways we have to move energy in our world is air or water. So, our distribution system, it's very hard to take a picture of a ductwork system, but forced air, heating and air conditioning. I can heat and cool your home through ductwork. It's a forced air system. But not all forced air systems are created equal. A properly installed ductwork system you should not feel or hear. Too many forced air systems were just not designed or installed properly. Okay. I have so many people that tell me they do not like forced air. I always tell them, it's not that you don't like forced air, you don't like to feel forced air. It's like the people that are afraid to fly. You're not afraid to fly, you're afraid to crash. Okay? Same way with a ductwork system. It's not the forced air you don't like, it was the design and the installation of it. We can also zone forced air. A geothermal system, a ground source heat pump, is a smart device. We can divide your house into multiple zones, 2, 3, 4, 5, 6 zones, that then talk to the unit and turn the unit up and down based on what the zone tells it needs. Only a ground source heat pump will do that. Your other forced air systems are on or off. So, it's a distribution system. It's a way to move the heat and the cool air through the house. The other part of a distribution system that we usually see fail are air returns. Every bit of air we move into a room, we need to get back. We need an air circulation. So, going into a house with one great big return somewhere in the ceiling, that's not a ductwork system. Every room should have a return in it. Okay? Flex duct. Nothing wrong with flex duct. But a bunch of flex duct thrown around your attic is not a ductwork system. So, we can have hydronic systems. Radiant floor heat. That's what this material is. Hot floors. You also may have heard that geothermal will not work with baseboard heat, which is just not true anymore. There are units out there, which we have, that will work with baseboard heat or radiators. Okay? When we're dealing with a hydronic or water system, radiant's more prevalent, but we can interchange with a boiler right now. We can make 150, 155 degree water. So you can have a hydronic system. Hydronic systems are wonderful, but the majority of people still would like air conditioning. The units are fully reversible. So if you don't install ductwork or don't have a forced air system, I can't give you AC. Your unit's just taking the summer off. And half the year you're not getting return on your investment. So by far the majority of the times we're either installing or modifying or reusing someone's forced air ductwork system. Okay? But generally they're the only two ways we have to move energy, air or water. Real quick review. 3 parts of a system. Ground loop heat exchanger. Well, when we have an open system, we don't have a heat exchanger, we just have a source of water. But we have a source of water coming in to get our energy from. The second part of the system is a ground source heat pump. They will all start with water, so they will either be water to water or they'll be water to air. Obviously, we're taking the energy from the water and transferring it either into a forced air or we're transferring it into another water, which we then distribute to the house. The third part is that distribution system. Radiant, hydronic, or some type of forced air system.